6 years ago, after becoming a bit tired of my usual mathematics, which is stochastic processes and Markov chains and such stuff, I went to internet and I've seen an article about Bitcoin, and it was interesting. And I thought, well, this is a really cool idea. Let me read about it, and let me maybe mine it and become rich, and so well, I started to read about Bitcoin, and then, of course, discovered that it was not so easy to mine it already at that time. So well, I started to read about also alternative cryptocurrencies. So there is this famous, or maybe infamous, internet forum called bitcointalk.org. So I've read quite a bit of it, and in particular there was an alternative cryptocurrency called NXT, which was a really novel concept for that time. It was a proof of stake, not proof of work as in Bitcoin. And well, I started to read about it, to dive deeper, and at some point, well, you know that blockchains have a lot to do with a thing which is called Poisson process. Well, basically, the times when the blocks appear, they form this Poisson process, which is a mathematical object which I know more or less well, because it's my area more or less. So at some point I just made some back of envelope computations about the blockchain of NXT, and then I posted these computations to the forum, and people say, wow, it looks good. Can't understand anything, but it looks good. So well, I became kind of known in this NXT community as an in-house mathematician of them. And when the creator of NXT, who is also Sergei Ivancheglo from Minsk, so when it came time for him to start a new project, he kind of invited me to be a mathematician of the project, and this project is IOTA. So right now we are a non-profit foundation registered in Berlin. It's more than 100 employees in many countries, and we have these. Does it work? Okay. Anyway, so the goal of the foundation is to research, develop the protocol. It is funded through donations from IOTA token holders, mainly. Well, so now we are more or less big, well, not really small at least, but back then in 2015 there were only 4 of us, so 2 Sergeis, David from Norway, who is our CEO, and Dominique from Italy, from Sud Tirol, in fact. He lives in Berlin. So there were only 4 of us, and yeah. So these are the interests of IOTA Foundation. And, well, just quickly describe what IOTA is about. So as I said, I consider Bitcoin in particular and blockchain in general a really wonderful invention, really genial. But this does not mean that it cannot be improved or developed further. So you know that in spite of advantages of traditional blockchains like Bitcoin or Ethereum, there are also some disadvantages, which are kind of slow confirmations. This is because in any blockchain there is a protocol imposed limit on the TPS, on the transactions throughput. And as a consequence of this limit, if the demand for inclusion to blockchain is high, then the transaction fees can also become quite expensive. I think in Bitcoin, in December of 2017, you could see transaction fees of like $50 per transaction. Well, so IOTA, we say sometimes that IOTA is a blockchain only without blocks and without chain. So when blockchain structure is blockchain has this structure. Now IOTA, the ledger of IOTA is called Tangled, and it is directed acyclic graph. So you see, I think it's not really visible, but there are small arrows here. So the direction is always from right to left, like this. And so you can think of every small square here as a transaction, or mini block, if you want. And it references or approves two other transactions, so here and here. So that's the basic structure. Well, I will explain later why this structure. Yeah. So far, one observation that I can make is that in principle there is no protocol imposed limit on the transaction throughput. So when more transactions are sent to the system, more validation you have, because, well, each transaction which enters, it must kind of validate, approve, vouch for two previous funds. The consensus rules are more or less similar in blockchain and in the Tangled. So in blockchain, the main rule is that the longest chain wins. In the IOTA Tangled, it's more or less the same. So the idea is that if your transaction is here, then it is directly approved by 3 other transactions, but these transactions are also approved by others, and they are approved by newer transaction and so on. So basically the whole stuff here approves this particular one. And sometimes a conflicting transaction may come to the system, but then the idea is that, well, when the nodes, when the participants of the network see that this thing here is not good, they will just stop approving it, and this thing, this fork, in a way, will die out just in the same way as it happens in blockchain. Now, the original motivation for developing all this, and which remains our main motivation still, is to make the feeless transactions possible for the use in the Internet of Things. So hence the name IOTA. It's derived from Internet of Things. Well, everybody understands, I guess, that in the Internet of Things, there should be many small transactions of small value, microtransactions, as we call them, or maybe even just transactions which have some data inside, but no value at all. Anyway, it's clear that you cannot really have transaction fees like in Bitcoin, because if you want to send 1 cent and you need to pay $1 of fee as a fee, it's kind of crazy, yeah. So then let's just reason. You want to enable feeless transactions. This means that the system which you want to develop needs to be collaborative. So the main idea is that I vouch for your transactions, you vouch for my transactions. I verify your transactions, you verify my transactions. I collaborate with the others collaborate with me. So the system needs to be homogeneous then. So you have to get rid of this dichotomy that you have in Bitcoin, miners and simple users. Because, well, miners are someone who invested in, let's say, mining equipment, like in Bitcoin, or they invested in the token as in proof of stake systems. But anyway, if you are a miner, you invested some resources to be eligible for that role. This means you need to make profit, and this means you will charge fees. So you have to get rid from miners, and okay, if there are no miners, then it's kind of difficult to make blocks, because who will make them? So you need to get rid of blocks, right? And you kind of naturally come to these directed acyclic graph structure because, well, if you don't have blocks, you don't group transactions in blocks. You cannot hope to construct a really blockchain because there will be too many stuff to organize it in a blockchain. So it's kind of natural that your ledger structure should be like this. Okay, so let's quickly look at the advanced properties of the Tangled, IOTA Tangled. As I said, the basic idea is that if your transaction is approved directly or indirectly by many other transactions, then it has a high confidence. So if it's approved by, if it's recent and it's not yet approved by many other transactions, it has low confidence, and transactions which just came and were not approved by anybody, so we call them tips, and well, they have yet to be approved. And the main rule, and in fact the only rule that we have in the Tangle, is that a new transaction which comes to the network must reference to other transactions. So the idea is that it must reference to tips. So if you want to put a transaction to the system, you have to choose two tips, for instance, this one and this one, and put your transaction with two arrows pointing here and here. Yeah, unfortunately, it's difficult to enforce this because the information does not propagate instantly in the network, so you cannot be sure that if you approve this tip, you cannot be sure that it was not approved by someone else maybe a second ago. So the rule that you have to approve two tips is not really enforceable, and so the main rule is that you just have to approve two transactions. And then the main challenge in this system is to devise the laws of the system in such a way that it encourages collaboration. It's, well, it's the usual problem. Like, consider BitTorrent, for instance. Many people like to download stuff from the internet, from the others, but they not always like to offer their resources to help the others. So in BitTorrent, for instance, they have to make some rating systems and such to kind of enforce the collaboration. And develop in IOTA, the idea is the same. The rules of the system, the behavior of the kind of default behavior of the actors should be such that if you help the others will help you. On the other hand, if you don't help the others, then the others will not help you. That's the basic idea. Well, anyway, right now it is done using the so-called Markov chain Monte Carlo tip selection. So there is a rule that you calculate so-called cumulative weights of the transactions here. Then you make a random walk which starts somewhere here. Then it goes like this in this direction, and then stops in the tip, in a tip. Then you run it twice, and you select two tips in this way. If you do this, you will help good guys, and you will not help bad guys. So if there is someone who does not want really to collaborate with the system and just approves two very old transactions here in order not to verify, not to vouch for other transactions, then this person can do this, but nobody would help him. Nobody would approve his transactions. So, yeah, that's the idea. So, as I said, one advantage of the system is that you have a single participant class, no dichotomy between miners and simple users, and you don't have any protocol imposed limit on the TPS anymore. So, well, of course there is a maximum TPS, but it's imposed now only by hardware limitations, bandwidth, and such things. So if you have a better hardware, you can just increase the throughput without having to change the protocol, the core protocol. So yes, it enables microtransaction economics, and also there is partition tolerance to some extent, because you can this graph can split and then remerge, provided that there are no conflicting transactions. Yeah, but if there are conflicting transactions, then it would be more difficult to merge. But at least if there are no conflicting transactions, then differently from the blockchain, you can do this. Right. Now, there are also unique challenges. Because, well, it's a more complicated ledger structure, and it's much more difficult to study it. Just mathematically speaking, a blockchain is purely one-dimensional. It's a deterministic structure, and here, this one is a random graph. So when you start, for example, looking at random walks on the random graphs, it's a very challenging task to just say anything theoretically about random walk of this sort. Well, so let me quickly skip it. This is, okay, anyway, just one comment. IOTA uses the so-called Winter-Nitz one-time signatures, which are supposed to be quantum resistant. They are supposed to be secure against a hypothetical quantum computer. So this is, well, because in the Internet of Things, you know, there will be probably devices which you would want to just put there and left unattended for 10 years. And now, can you be sure that in 10 years there will be no quantum computer which will break the conventional public key cryptography like ECC and RSA and such? So, we have chosen to make it quantum secure just from the beginning. Of course, it comes with some cost, and which means larger signatures, but well, there is always cost when you want to. Now, right now, in the, so how much time do you have? Okay. So right now we have a finality device in the network which is called the coordinator. Coordinator is basically just a node which issues special transactions called milestones. And the current rule in the system is that transaction is considered final if it's confirmed by a milestone wait. So the goal is to remove this coordinator in order to make the system truly decentralized. And we call this project the core decide. Now this should be read from bottom to top. Just let me quickly explain. So there is a site, coredecide.iota.org, with a lot of beautiful stuff in there, and there is also a white paper. We have to update it already, but well, hopefully it will happen soon. But the first version of this of the core decide white paper is there, and also there is a channel in the community Discord called Tangled, where we discuss the questions related to mathematics of IOTA, right? And in particular, we discussed the core decide. So here are some ideas which make the core decide possible. Well, there is node accountability, means that nodes will have some IDs, and if a node is doing something bad, then others will not like it. It's like in human society. If you don't behave well, you will feel the consequences. Well, there is a special auto-peering system. I think I will not speak a lot about this now. There is a thing called mana, which is more or less a a variant of, I wouldn't say it's proof of stake, but well, it's basically when you do a transaction with value, you can say, I bless a node number n with this value. And this constitutes this mana. It's not really so mana is not token, it's just for Sybil protection. Okay. Then we add a voting layer, which means that the nodes can resolve conflicts proactively instead of waiting until the heaviest tangle wins. They just can talk to each other and decide which is good, which transaction is good and which is not good. And there is a paper of Bill and myself, which is called Fast Probabilistic Consensus with Byzantine Infrastructures, which is in the archive. And this is basically a protocol which permits to the nodes to talk and decide. And well, the general idea is that we look for a probabilistic consensus. That is, we come to consensus with high probability, and high probability means really high probability, such that there will be consensus until the sun fades out. And the idea is that even if you have a not really complete consensus on some past state, even if it's a bit approximate, you can somehow use it to achieve a complete consensus on the present state with very high probability. And then it kind of sustains itself. So we call such things attractors in mathematics. So if you are here, and then if by chance some force drives you a little bit away, the rules of the systems are such that you will come back. And this point which attracts this dynamics is the consensus. So yeah, the consensus will remain, and in practice it will be perfect. I mean, the failure probability should be so small that it will never stop. Oh, okay, so I think I have to stop here. Sorry for.
Sorry, guys, just a little bit over time.
Yeah.